Everybody, welcome back to Mr. Muller's 8th grade 5th hour science class. Today we're going to talk about what causes seasons, and we'll talk about a few other things like solstices and equinoxes, and that'll be the end of lesson 1.2 in the textbook. Okay, so I'm going to read pages 14 through 17, and then I'm going to go over this PowerPoint. So if you want to skip one or both of those things, because I did go over this PowerPoint yesterday, I actually got a little ahead of myself and went through the seasons, equinoxes, and solstices. But I'm going to go over it again today after the reading, because it makes more sense. Then I'm going to talk about the Google form questions that you'll have to fill out, as well as the flip grid from yesterday, and then the new flip grid that you're going to have to do tomorrow for your assignment, and the other thing you have to do for your assignment as well for tomorrow before you get a 3-day break, 3-day weekend. So let's start on page 14 if you're following with me in your textbook. What causes seasons? Many places that are far from Earth's equators and its poles have 4 distinct seasons: winter, spring, summer, and autumn. But there are many differences in temperature from place to place. For instance, it is generally warm near the equator and warmer near the equator than near the poles. Why is that? We're going to learn in just a second. How the sunlight hits the Earth. Figure 3 shows how sunlight strikes Earth's surface. Notice that near the equator, sunlight hits Earth's surface from almost overhead, directly. Near the poles, sunlight arrives at a steep angle. As a result, it is spread out over a great area. That's why it is warmer near the equator than near the poles. So that makes sense. Now we all know the Earth's axis is tilted. Okay, 23.5 degrees. We're going to read that in just a second here too. Whether the northern hemisphere is pointed towards the sun or whether the southern hemisphere is pointed towards the sun, regardless, the poles get less heat because there's more direct sunlight towards the equator than the poles. Even when it's tilted towards it, the middle is still getting a more direct hit. Okay, which doesn't make a ton of sense, but really what you need to know is the reason why the equator has no seasons is because they get a constant direct hit of sunlight in the middle of the Earth. If the Earth didn't tilt on its axis, we would get warm tropical weather from pole to pole throughout the whole globe. Earth's tilted axis. If Earth's axis were straight up and down relative to its orbit, temperatures in air would remain fairly constant year-round. There would be no seasons. Earth has seasons because its axis is tilted as it revolves around the sun. Notice in figure 4 that Earth's axis is always tilted at an angle of 23.5 degrees from the vertical. The North Pole always points in the same direction. As Earth revolves around the sun, goes around the sun, the north end of its axis is tilted away from the sun for part of the year and towards the sun for part of the year. Summer and winter are caused by Earth's tilt as it revolves around the sun. Next page 15, June. In June, the north end of Earth's axis is tilted towards the sun. In the northern hemisphere, the noon sun is high in the sky and there are a lot more hours of daylight than darkness. The sun's rays are concentrated. It is summer in the northern hemisphere. At the same time, in the south of the equator, the sun's energy is spread out over a longer area, right? It reflects, it kind of bounces instead of that direct sunlight. So the sun is low in the sky and days are shorter than nights. It is winter in the southern hemisphere. December. In December, people in the southern hemisphere receive the most direct sunlight, so does summer. At the same time, the sun's rays in the northern hemisphere are more slanted and there are fewer hours of daylight, so does winter in the northern hemisphere. Okay, next page 16. Solstices. The sun appears farthest north of the equator once a year and farthest south of the equator once each year as well. Each of these days is known as a solstice, the day when the sun appears farthest north in summer solstice in the northern hemisphere and the winter solstice in the southern hemisphere. This solstice occurs around June 21st each year. So June 21st is obviously our middle of the summer. It's our summer solstice. That is the winter solstice for the southern hemisphere at the same exact time. It is the longest day of the year in the northern hemisphere. So what is it in the southern hemisphere? It's the shortest day of the year. So as you can see in figure 5, the sun rises to the northeast and sets to the northwest. Okay? You can see that down there in the picture there. Similarly, around December 21st, the sun appears farthest south. This is the winter solstice in the northern hemisphere and the summer solstice in the southern hemisphere. The sun rises to the southeast and sets to the southwest. Equinoxes, about halfway between the solstices, neither hemisphere is tilted towards the sun. So again, we have times where it's tilted, the northern hemisphere, the top of the Earth is tilted towards the sun. Then we have times where it's tilted away and the southern hemisphere is tilted. But there are the times where it's in the middle, and we call those equinoxes, where neither hemisphere is tilted towards the sun. And that's the seasons like spring and fall, if that makes sense, right? It's kind of a milder weather. The noon sun is directly overhead at the equator, rises due east and sets due west. Each of these days is known as an equinox, which means equal night, equal day. During an equinox, day and night are each about 12 hours long everywhere. The vernal spring equinox occurs. Bless you. You made a mess over there with the macaroni. Uh, the vernal spring equinox occurs around March 21st. It marks the beginning of the spring in the northern hemisphere. The fall or autumnal equinox occurs around September 22nd. It marks the beginning of the fall in the northern hemisphere. Last page here. Let's do the math. Why not? Calculating percents. The table shows the number of hours of sunlight in 3 cities at different times of the year. What percentage of the 24-hour day has sunlight in Guadalajara on January 1st? So you're going to divide the number of hours of sunlight by the total number of hours. So the hours of sunlight, if you look down into the green box on there, Guadalajara, Mexico, you go over to hours of daylight, January 1st, you get 10.9. You can divide it by total hours, which obviously can be 24, and you're going to get 0.45. Multiply by 100 to get the percent. So 45% of a 24-hour day has sunlight in January 1st in Guadalajara, Mexico. Okay, let's do assess your understanding so we can kind of wrap things up here. The noon sun is directly overhead at the equinox. Excuse me. The noon sun is directly overhead at the equator during the what? It is the equinox. What causes the seasons? As Earth... I know she's working, bud. Hold on a second. As Earth orbits the sun, so as it revolves around the sun in its orbit, it changes the amount of sunlight results from the tilt of the Earth's axis. So as the Earth goes around, sometimes it's tilted towards the sun in the top, or sometimes the bottom is tilted towards the sun. Sometimes it's in the middle. But those seasons are caused by the tilt of the Earth's axis as it revolves around the sun. Letter C, predict. How would the seasons be different if Earth were not tilted on its axis? We talked about this. Temperatures remain mostly constant all year round, and both hemispheres would receive the same amount of sunlight all year. Some places would still be tropical and hot in the middle, but I think the northern's like above the equator. Okay, you get like spring and fall type weather all year round. Okay, so that is that for the textbook. If you guys have any questions or anything, please email me, all that good stuff. What is this? Oh, I figured out I can do that. It's too late now. When I record, it doesn't let me stop screen sharing unless I stop the whole video. So I'd prefer to screen share, maybe just show the video, and then when I'm doing this, screen share this, but whatever. What causes the seasons? Like we talked about several times, Earth has seasons because it tilts. Its axis is tilted as it revolves around the sun. This tilting results in temperature difference because different latitudes or different spots on the Earth, right? So low latitude, middle latitude, high latitude of the Earth receive different amounts of sunlight. So one thing I want to talk about yesterday is it's a misconception. The closer you are to the sun when the Earth is in its orbit, the hotter it is. That's actually not true for the northern hemisphere. That's when January is when we're closest to the sun in the northern hemisphere, but obviously it's very cold. That's one of the hotter months of the year for the southern hemisphere. To what degree is Earth tilted? 23.5. I heard that number 100 times, I think. When is it summer in the northern hemisphere, and what is happening in the south? So it's going to be the opposite. When it is summer in the northern hemisphere, it's going to be the winter in the southern hemisphere. Makes sense, right? And that's because the northern hemisphere would be facing the sun during the summer months, May, June, July. What is a solstice? Solstice occurs when the sun is the closest north or highest in the sky, or when the sun is closest south, lowest in the sky, when they're tilted towards or away from the sun at their highest moments. What are the dates of the solstices on Earth? In the northern hemisphere, again, it's June 21st, which means the winter solstice in the southern hemisphere is December. Oh, excuse me. Sorry. In the northern hemisphere, June 21st is the summer solstice. So that means June 21st is the winter solstice in the southern hemisphere, and it is the longest day of the year for the northern hemisphere. December 21st is the winter solstice for the northern hemisphere. It is the shortest day of the year, and the opposite is true for the southern hemisphere. It is the longest day of the year on December 21st. It's their winter solstice. The other thing is equinoxes. That's equi or equa means equal, so that's the word inside of equinox. Equinox occurs when neither hemisphere is tilted more towards the sun. On an equinox day and night, it's about 12 hours everywhere. What are the dates? The vernal equinox or the spring equinox occurs on March 21st in the northern hemisphere, and the autumnal one or the fall one occurs on September 22nd in the northern hemisphere. It's the opposite for the southern hemisphere. Okay. I might have mixed up northern and southern hemisphere a dozen times in that. I apologize. Hopefully, you just read from the slide and you did the reading. It all makes sense. So, when you are done, you're going to. La-di-da, la-da-da. Okay. It'll be posted, but you will click. It'll be posted by the time you watch this video. But you're going to go to Google Classroom and click on the Google form question and answer the questions based on the reading. Tomorrow, as you can see, I'll show you in just a second here. You know, there's always technical difficulties in Mr. Muller's class here. Tomorrow, you're going to do what are 2 new things you have learned about space so far since we started last Tuesday. Right, Monday was just kind of a check-in. Describe what your typical day is at home with distance learning. You're going to do this on Flipgrid. Then there'll be an ed puzzle. Everything revolves around you, obviously about revolution, sun, earth, and moon. You know, a little bit about Flipgrids. I know it's the first time. Okay. Wow, Jack. It's a beautiful drawing you have there. I know, Steven, really. I know this was the first time, so some of you kind of didn't know what to do. But when I say make a video showing the difference between rotation and revolution, the ones that I got so far, you guys did this, you discussed it, but that's kind of like a little boring, right, guys? You're just kind of doing what the teacher does. I would prefer that you guys use yourself, other people, or objects to explain the difference in sort of a creative way. Some of you, it's going to be a little bit tougher, but you know, I saw some of Miss Meyerson's Flipgrid videos. Some of her kids were using objects like, you know, a baseball and a golf ball, or they're using different objects to represent it. So try to be creative. Don't just sit somewhere and explain it to me for 15 seconds. I would prefer you to do a little bit longer than that. And another thing, don't do it from your bedroom. Make sure you're wearing appropriate clothes. Make sure you're saying appropriate things, just like you would in school. So don't do it from your bedroom, guys. Just like when you do Zoom calls and meetings and stuff, don't do that from your bedroom. Okay. So that is that. The other Flipgrid will be up by the time you watch this. Excuse me, it will not be. The Flipgrid, the other one is for tomorrow. That's what you have learned about space so far. A couple of things you've learned about space so far. And then the Ed Puzzle video. Okay, so that should be all that we need to talk about for today. If I'm trying to think of things. You know, it's funny. I always think about things I want to add to the video after it's done. And if it's a 15-minute long video, I do not want to redo it. And I'm not at the level of editing and stuff. But anyways, thank you guys for listening. And we'll talk to you guys very soon. Have a wonderful rest of your day. Thank you.